Mi-TEC 2024. I am Hanis Farha.
I am Siti Shahira.
Will be your MC for the opening ceremony today. Before we start, we would like to request everyone to rise for national anthem, Negaraku and MAHSA song. Please rise.
Menggapai cita, mengotakkan impian. Kita sang juara, meneraju cemerlang. Merintis laluan gemilang, aspirasi negara dijulang. Semakan keyakinan seluruh warga, kita mantapkan jaringan antara bangsa. Di sini lahirnya nasional berjaya. Kita lakukan di pentas dunia, Universiti MAHSA, lambang kejayaan. Universiti MAHSA, satu kemegahan. Universiti MAHSA, menuju kemaksyuran. Universiti MAHSA, bersih pilihan. Berdaya saing, berinovatif, berdedikasi, berintegriti, melahirkan insan berkualiti, bangsa jadikan satu realiti.
Ladies and gentlemen, please be seated. Without further ado, I would like to call upon Mr. Muhammad Mikail Rafiq to recite the dua.
Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala mursalin wa ala alihi wa sahbihi ajma'in. Allahumma innaka khalaqul azim, innaka sami'un alim, innaka ghafurur rahim, innaka barul jawadul karim. Praise be to Allah, the Lord of the world. Peace and blessing upon our Prophet Muhammad sallallahu alaihi wasallam and his companions and those who follow his example till the judgment day. Allahumma ya Karim ya Rahim. On this blessed morning, in conjunction with the MAHSA International Technology and Engineering Conference 2024, we beseech and grateful towards you, Ya Allah, in the favor of all the infinite blessing to us, your humble servant, to live in a safe and prosperous life. We seek your blessing for flawless progress of this event from the beginning till the end. We seek your guidance to steer clear of events that will detrimentally affect the progress of this event. Ya fa'alu lima yurid, Ya Latif, Ya Rahman. Please bless us with your tawfiq and hidayats. Please guide MAHSA University to greatness, peace, glory and prosperity. Make us your righteous servant that follow your commands and neglect the sinful act. Oh Allah, please forgive us for our wrongdoing. Ya Munzil al-Barakats, bestow peace to our beloved country, Malaysia. Preserve us from any threat and disaster. Bestow patience in us in order to face the upcoming challenges. Please accept our deeds and please reward us accordingly. ربنا عليك توكلنا وإليك أنبنا وإليك المصير. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. وصلى الله على محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين.
Thank you to Mr. Muhammad Mikael Rafi for the recitations of Dua just now. Honorable guests, ladies and gentlemen, Mi-TEC 2024 aims to bring together academicians, researchers, and industrial professionals from all over the world to share their experiences in the field of engineering and technology. It provides a platform for researchers, educators, and students to present and discuss the most recent innovations, practical challenges, and solutions adopted in their field. The scope of the conference is to encourage the research and innovative ideas, focuses on digital transformation and green technology toward Industrial Revolution 4.0 in the field of electrical and electronic engineering, mechanical engineering, and information technology. The topic of interest for submission includes Internet of Things, IoT, renewable energy, machine learning, robotics and industrial automations, manufacturing, and smart materials toward IR 4.0. The theme of Mi-TEC 2024 is Digital Transformation and Green Technology towards IR 4.0. To begin this event, we are pleased to have Yang Berbahagia Profesor Dr. Rosna Zain, Deputy Vice Chancellor MAHSA University, Yang Berusaha Associate Professor T.S. Dr. Imam Farshi, Dean of Faculty of Engineering, Built Environment and IT, MAHSA University, Yang Berusaha Dr. Rusdi bin Matsong, Conference Chair Mi-TEC 2024, Yang Berusaha Dr. Chua Wen Shan, Head of Malaysia Smart Factory 4.0 Selangor Human Resources Development Center, and all from KS Rangasamy, College of Technology, and respected guests. Distinguished guests, ladies and gentlemen, to begin our ceremony, let us welcome Professor T.S. Dr. Imam Farshi, Dean of Faculty of Engineering, Built Environment and IT, MAHSA University for his welcoming speech. Please welcome.
Good morning, everyone. Thank you for joining us for this conference. Good morning, all the attendants. We have a distinguished guest all the way coming from India. Thank you so much for joining us. We have today our Deputy Vice Chancellor for Research in MAHSA, Professor Rosna. Thank you for joining us, and all our distinguished colleagues and our students in Faculty of Engineering, Field Environment, IT, MAHSA University. So basically, this is our fourth conference focusing on the MAHSA International Technology Engineers Conference, or Mi-TEC’, which we start this conference from 2020 so far. So this is fourth time that we conduct, and we are happy. So we started back 2020 when it was in COVID time, and it was online. So now this is hybrid mode, and I'm happy to say that we have more than 60 papers submitted for this conference. So for our faculty, we have 3 conferences per year, which is first focused on the Mi-TEC technology, mostly focused on the IoT, AI application background of electrical, mechanical engineering. So this is the basis of all whatever field is that. Our next conference, MAHSA, is focusing on the constructions, build environment, civil engineering, and final one is IT. So basically, if you think why we do this range of the conferences, because everything starts with this AI, IoT, robotic application for any field. So if you, I don't know, especially our Malaysian friends, if you go even nowadays, very cheap, cheap price restaurants, which is focused on the Mamak restaurant. Even that Mamak restaurant with a very small amount that you pay for your food, nowadays they use robots to move your food. So you see that how these technologies apply even for the very low price restaurant. And even now, I was looking for the papers topics that it is submitted. Just I opened one, and the one that it is in front of me, it is early heart attack detection with portable heart rate monitoring using IoT technology. So even you see that this IoT technology, AI technology, how it's affected on other fields, which is all basis, even medicine fields, they have to use this kind of technology and information to develop their knowledge, develop their technologies for any field. So that's actually, it is also the first conference of the year in MAHSA as well. It shows the importance of this technology application in any other field and other faculties that we have in MAHSA. We do have dentistry that's always also, they use all the technologies of robotics, AI, and 3D printer or anything for their applications. We have medicine, health science, and all it is a startup, this IoT and AI. So I opening this because I want to say that for those researchers in these areas, I hope that understand that the importance of your knowledge. So hopefully today, by sharing the knowledge of all the latest technologies in these areas, we can help our surroundings and our area and our worlds to become more advanced in any area. So we are the one that help our world to develop in any other fields. So you should be proud, and also you should share your knowledge that to make sure that all other fields in any areas can be developed as much as possible. So hope everyone can enjoy this our today conference and make sure sharing the knowledge improve our knowledge for any other fields, and hope we have a productive day today. Thank you so much and have a nice day.
Thank you, Dr. Iman, for the wonderful welcoming speech. Ladies and gentlemen, next, we would like to welcome Yang Berbahagia, Professor Dr. Rosnah Zain, Deputy Vice Chancellor, MAHSA University, to deliver the opening speech. Please welcome.
Assalamualaikum and a very good morning. And I would like to welcome to the 4th MAHSA International Technology and Engineering Conference 2024, themed Digital Transformation and Green Technology towards IR 4.0. And on behalf of MAHSA University, I extend a warm welcome to our esteemed guests and all participants. To who are delegates, researchers, scholars, and practitioners who gathered here today. The theme of this conference is Digital Transformation and Green Technology towards IR 4.0. And it could not be more pertinent in today's rapidly evolving technological landscape as we stand on the brink of the fourth industrial revolution, characterized by fusion of digital technologies. The boundaries between the physical, digital, biological spheres are becoming increasingly blurred. The revolution presents both unprecedented challenges and opportunities across various sectors, particularly in electrical and electronic engineering, mechanical engineering, and information technology. The scope of this conference is meticulously crafted to encourage research and innovative ideas that focus on leveraging digital transformation and green technology to propel us forward into IR 4.0. So the aim of this conference is to explore how advancement in areas such as IoT, renewable energy, machine learning, robotics, and industrial automation, manufacturing, industries and societies worldwide. There are a number of tracks in this conference, and or rather two tracks. And in track one, the conference will delve into electrical and electronic engineering, IoT and real-time monitoring, machine learning techniques in intelligent system, renewable energy, robotics and industrial automation, and nanotechnology for green energy. In track two, this intends to explore industrial IoT, artificial intelligence in reliability, manufacturing processes through IR 4.0, smart and advanced materials, and robotic structures and applications. So these tracks are actually designed to provide a comprehensive platform for discussion and collaboration among experts in their respective fields. And it is also crucial to highlight the current applications of IR 4.0 and IoT across industries. Here we are witnessing a transformative wave sweeping through various sectors from healthcare and agriculture to manufacturing and transportation. The integration of IoT devices and systems in revolutionizing processes, enhancing efficiency and driving innovation across the board. So it is imperative that we continue to explore and harness the full potential of these technologies to address societal challenges and drive sustainable development. So as we embark on this journey of exploration and discovery over the next few days, I encourage all of you to actively engage in discussions, share your insights, and forge collaboration that will shape the future of technology and engineering. So together, let us charge a course towards a more sustainable, connected, and technologically empowered future. So once again, I extend my heartfelt welcome to each and every one of you, and thank you for being a part of Mi-TEC 2024. I wish you all a productive and enriching conference. Thank you.
Thank you, Prof. Dr. Rosna Zain, for the insightful opening speech. Next, we have keynote sessions. The first keynote speech is going to be delivered by Yang Berbahagia Professor Dr. R. Gopalakrishnan, Principal, KS Rangasamy College of Technology. Prof. Gopalakrishnan studied Bachelor Engineering in Electrical Engineering at Banari Aman Institute of Technology, MA Power System at Annamalai University, and conferred his PhD Power System at Anna University, Chennai. During his tenure, new initiatives, namely startups and entrepreneurships, were introduced as mandatory courses. Mentorship sessions were conducted for excelling students, and this paved way for 14 startups from students. The topic title that we delivered is The Importance of Artificial Intelligence and Internet of Things in Industry 4.0. Without further ado, I would like to welcome Professor Gopalakrishnan to deliver the speech. Please welcome.
So thank you, MOC. Happy morning to all. Salamat Pahi and Namaste. So I'm Gopalakrishnan. Thanks to MAHSA University for providing us an opportunity. It's a pleasure joining with you and organizing this conference. So today we are all in a smart and digital world. So the topic also, it's a right topic. The importance, so the International Technology and Engineering Conference, the fourth conference. And today I'll be sharing my few thoughts in importance of AI and IoT for Industry 4.0. Next slide. May I have the slide change? Yeah. So probably just start with small exercise. So what is SMAC world? Probably the audience, if you could help me, it would be really great because it's again relevant to the topic as well. SMAC world. It's a we are living in the world SMAC, social mobility. Yeah, probably next. Yeah. And analytics and cloud, because this is what the theme of your IoT and AI. That's one of the important thing. Probably then another word which we are again we are very much particular about it. The next one, GPT, because we are again we are saying chat GPT for anything and everything. So with the open AI, we are talking about chat GPT. We must know what is GPT again. So GPT, so so probably you may be knowing it is generative pre-trained transformers. So that's what your the bots, what actually the things are doing. So it's from AI. So that's what my the entire session would be. So moving on. So I think you have the mobile app called Grab. So in Malaysia, now last 2 days we are experiencing a lot. So if you could do one small exercise, probably not now, even later also. It just I was doing in a small, to connect it with the AI. So how this machine is working. So I just destination as a university. So if you look at your trip is just short walk away from pick up further destinations. So it is telling us. So it is very short distance. So think about it's a little. So that's what it is from. It's a kind of an experience from your Grab app. So this is what probably the AI is doing in detail. So being a human, we may make a lot of errors. Okay, but to make this particular command, so it says that choose destination, change destination. Okay, so you need to have lot of training and lot of inputs. So minimum some meters, 600 meter or 800 meters, 1 kilometer. These are all coming in the algorithm. So that's what it's all about. Your GPT, and it's all about our AI is all about. It's a small AI experience. I have one more experience. This is an IoT experience. So we call it as Internet of Things, Internet of Everything, and industrial Internet of Things, and AIoT. It's all the buzzwords. So here, again, it's the picture which you're every day when you're traveling to a university, when you're traveling to KL or anywhere, you'll be able to witness. So here again, so it's in a smart tool in Malaysia, and you have different classes as well. There are 7 classes in Malaysia. These are the pictures which we have taken. And here one thing I wanted to tell you, the entire black diagram of IoT, because I connected with the SMAC, mobility, data analytics, and cloud. So here we have sensors. We play around with the sensors, the so-called the Arduino and whatever the device you call it as, it all will be collected from the tag. It may be RFID or it may be NFC. And from that, the data will be compared, and there are stored here, and it will be retrieved later also. One is the register number, the registration number of vehicle. It's all you will be able to make with the intelligence. One thing, if suppose there is no smart tool, if suppose human operating, so I have a vehicle with multi-axle, a vehicle with 5 axles and more, whereas I'm charging only for the car. It is possible. So that's what we call it as an intelligence. The IoT experience with an intelligence is possible only if you go with the smart. So that's the scenario here. So if it is a human, yes, it not only error, there are the other possibilities also. So these are the 2 experiences I wanted to give away to the audience. Thank you. Yeah. So it's again we know very well what is a human intelligence and what is a machine intelligence. That's what we call it as an artificial intelligence. The important thing which we have here, we are very much weak because of the memory. We may not able to retrieve the data as and when required. But whereas the machine, based on the algorithm, based on the processor speed, you will be able to know quickly we can do it, and you can also take the decisions. So human decisions more of sympathetical or empathetical, but the decisions of the system, it would be more of process oriented, not the empathetical or sympathetical oriented. And this is again another problem. Only in machine, sometimes it may be also no struggle. If suppose the data is unknown, if the data is trained, if the data is relevant, yes, it can take and it will take the decision. Otherwise, there may be here also we have some problem. But if you based on the continuous training, based on the continuous experience, we will be able to make things in better way. Next. And again, this is an important slide because I'm addressing the research audience, because how this AI and how the intelligence takes place and what actually we have to do to make a lot of research in this particular AI and IoT. Because we deal IoT in many applications. We talk about industry 4.0 or 5.0, or you take anything for that matter. So it starts with anything, it starts with the mathematics, because the modeling is one of the important thing which we have to think about. So after the modeling, this is a basic then we converted as an artificial neural network from, because it's artificial intelligence, it's not a new term which we are using, because it's at least, if you ask our deputy vice chancellor, she will tell during her time she was studying, or she was come across the neural network and fuzzy and all these things, because we were doing most of the research in fuzzy and artificial neural network. So now it emerges as an artificial intelligence. So it's based on a lot of training, and so these two are the another important thing which, when we are doing the artificial modeling, the classifier and statistical model. Because when we talk about artificial intelligence, because the data is an important aspect where we have to do lot of things, because trained data and normal data, and time to time it will change. So these two are the important thing, because it is in a continuous changing also. So based on that, we can also use different algorithms. That's where the research lies. And here I also wanted to compare one more thing, the AI, how it has come into a different process. So we have to take into two things. One is machine learning. I also want to take you in another experience. You just take a child, probably our wards or whomever may be for that matter, when they are in the age of 1 or 2 or 3. So they may not be able to know things. Probably that would be my next slide. So I will be connecting with that. So machine learning and deep learning, I also wanted to connect with the human learning. So probably the next slide will help me. Yeah, these are the different ages of our childhood. And it may be a verbal, or it may be an action oriented, or lot of things are there. So based on that, we'll be able to learn. There are three kind of learning. One is cognitive, that's what more of a memory oriented, and when you grow up, and associative and autonomous. Now we are in this particular learning mode. So this I am connecting it with your machine learning and deep learning. So when you are autonomous, it would be only possible when you come across all this learning. So unless otherwise you have all this learning, you cannot able to take a decisions. So unless you become autonomous, so this kind of a learning will be applicable for all the cars. If say, for example, the future cars, autonomous vehicle. So that's what I'm just connecting to that particular aspects. And here you just look at the same thing, the human learning, the intelligence, it's more of a models, algorithm. And the next one, the learning materials, it's more of the collective data. So time to time it will change, and the learning skills. So we are going with the three different things. It's not only three, it's a number of process. So right from the childhood, we are learning. The same, it will be applicable to the machine learning and the deep learning. So that's the scenario. So with that, yes, we'll be able to write lot of algorithms. You can also come out with a new algorithm based on different process. Next. Yeah. So now, what actually exactly the difference between Industry 4.0 and 5.0. So Industry 4.0, we all know it is a cyber physical system. So more of how we are connecting the different machines and different process with internet and all these things. Now we are also adding with augmented intelligence, because the artificial intelligence, the augmented intelligence, more of it's a machine oriented. The augmented intelligence, where it is in a human operated intelligence. That's the difference. So we have wanted to apply this human and machine collaboration. So that's what we call it as an Industry 5.0. Moving on. So you will be able to see the difference. So human with the machine. Very simply, if you want to take the first one, it's only with a human or machine. That's the Industry 4.0. Here, it is a combination of the both. So either it is in a machine, there may be a problem. If it is in a human also, there may be a problem. Combination of both will be ruling the world. So that's the input that I wanted to give. So here, what we are going to do in terms of different process. Because when we go for a network, when we go for an IA, when we go for an IoT, because it's all dealing with the cyber. So there we have a lot of other challenges. It may be a problem for phishing or problem for security related. How are we going to come across, or how are we going to address those things, or the again opportunity for the research. So again, we can take specific problems, and we will be able to apply our process, and we will be able to apply our algorithm. We'll be able to solve it. Yeah. So this is a basic thing. Yeah. Thank you. It's okay. This is the point of it. Yeah, it's okay. Yeah, good. So I don't need to explain IoT in detail. Probably we are all living in this world. It's a connecting all the devices in the internet, very simply. So for that we need the sensors and the transmitter and all the stuff. It's all connected with the internet, and so for this IoT, it gives a high user experience. So that's the one of the key which we wanted to talk about. So by having a high user experience, we'll be able to make the process very, very easily with the AI in connected. And these are the emergence. So now, at least when we talk about IoT, earlier it was only 2% of the devices connected in the internet. Now the things are moving. Probably after some time, by 2030 or 2040, so almost 100% of the devices in the world connected with the internet. So by the time, we'll be now sitting here and doing everything only with a small handheld device. So that's the process. So this is again. So what actually we are going to do, particularly this particular process, as I said. So how we can contribute, that's what our main objective here today, the research, because as our Dean has mentioned, what actually we are going to do but in IoT environment. So here in IoT environment, one of the important problems which we have come across is the security. Okay, so that we can, cyber security may be one of the concern. And the second one, how we can transfer the data without any difficulty, without by having different networks, because we started with Wi-Fi, we started with different range of networks. So that is also again another important thing where we can think about. And moving on. So here I want to take, at least there are a lot of applications, there are a lot of specialization which involved. I want to take only three things. Probably healthcare, one of the important thing for a human, and the second one electronic EV vehicles, autonomous vehicles, and smart factories. These are the things which today I wanted to take it, and probably how this IoT will help the GDP of any country, because if you increase the production, if you increase the automation, probably you will be able to address the different disruptions. You will be able to address the economic growth of the country. So that's the point which I wanted to highlight today. So obviously, any the digital or smart things will be look like a disruption, but we have to take it in other side. It would be in a constructive technology. That's what I wanted to insist upon. So obviously, if you look at this is in a data which we have taken. So how this Industry 4.0, particularly because of IoT, which is helping the countries, both India and Malaysia, because both working together in many aspects and in friendly countries. So if you look at it is increasing 30% of the job growth in both the countries and also 20% of the GDP growth. It is again the data now for the purpose of financial aspects. And it is again a case study after implementing the IoT, how it is improvising the operations in particular companies. You take, see, there are three companies we have taken, company A, B, C for the want of name. We have not taken the company names. So there are increase in the production and the new benchmark also been set in the smart manufacturing. So that's one of the key process. So these are company B and C. After adoption of IoT enabled supply chain, because in the industry we will be able to know it is not only into production, it is also supply chain and also into another process like various market demands and the customer preference and customer relationship management. There are so many things involved. So it all finally results increase in the process supply chain management, which is also reducing the operational cost. So that's the important thing. It is also ensuring the sustainability. And this is what I wanted to highlight. So we'll be able to have enhanced production. So that's the key here. It's more of data driven. So the decision making will be very, very easy. So the problem, one great advantage, so you will be able to agile and proactive, and the decision making will be very, very fast. And the next one, what would be the problem? That's what I was telling. One is the data security and integration complexity and human machine adaptation. Because as I said, augmented intelligence. So when we combine both the human and machine, there will be challenges. So that need to be addressed. Probably we'll have one of the research topic and integration complexity. Because when we keep on adding machines in the IoT, so the complexity of the system will be increasing. Say, for example, only this projector, that won't be a problem. So in this particular room, you have a projector, you have a mic, you have an audio system, you have an HVAC, and you have other stuff as well. So if you add this particular room, at least we have 6 different devices. For each and every device, we need a sensor, different sensors, and it has to be connected in one particular processor. And it may be a small and complex. But whereas if you look at a big industry, earlier we were using only the PLC and SCADA. Now if you go for IoT, again, the complexity will be very, very high. So for that, we should be in the position to write different algorithms to solve that complexity. In terms of a hardware, in terms of a software, both it has a complexity. But now because of the advancement, everything, it becomes very small. So because of the process and other stuff. And this is again smart manufacturing, connected supply chains, integration, and how we can, the 5.0 and IoT, it would be a user-friendly and eco-friendly. And so this is again another topic which I wanted. One is the smart manufacturing. The second one is autonomous vehicles, which I was talking about. So how this IoT can make a difference in autonomous vehicles or in electric vehicles. So now we are experiencing a normal vehicle. Either it may be it was IC engine, now only with the electronic sensor related. And moving on, the vehicle would be fully automated. So either normal. So for your information, a normal car will be having at least some hundreds of motors. You won't believe, more than hundreds of motors. So all the motors will be connected with the Internet of Things. So if you wanted to feel this particular window to be opened or particular clutch to be controlled or whatever maybe AC, it is possible. If you wanted to increase the AC, feel a suffocation inside the car. Sometimes if you wanted to increase the AC or decrease the AC, everything it is possible. So that's the great thing in using the IoT in an electric vehicle. Not only that, say for example, you are parking, because already it's all available, in reverse and adjacent 1 meter or 1 feet, or you can avoid. So enhanced performance. That's what I was mentioning about. And the second one, improved safety. So all we need to have is the safety. So then finally, real time. So everything it is possible when you go with an IoT. So it is not only in smart manufacturing, it is also possible in the vehicles. It's more of we'll get user-centric solutions and data-driven characteristics. And it is also possible to know when we are going for a charging, because there is a process called the BMS, battery management system. And apart from that, will be considered as a node. We can also have in a grid of vehicles, and there also we'll be able to know monitor in a dashboard how things are happening in a particular road or particular city. Everything it is possible in the so because normally we know about the base load and peak load process. So when we go for a peak load management, also it is possible and to avoid discontinuity or peak load stress. Even if suppose you wanted to know, I look at it in a two different perspectives. This peak load stress, one is on in terms of traffic, or another one is in terms of charging. Both it is possible. That's what the peak load stress is all about. Second, the same thing, the theft prevention. So it's another future which we can have it in the IoT and preventive care, everything, early detection, everything is possible. So this early detection, I just also wanted to touch upon digital twin, because all of you heard about a process called a digital twin. So if you have a digital twin in place and the IoT in place, easily you will be able to identify, suppose you're driving to getting Highline. So in between in the night, by 11:30, somewhere, your engine get collapsed. Probably it will get information at least 5 minutes before to your mobile. So you will get a caution notice or caution message, a pop-up message or mail. So by the time you will be able to plan your process next for 30 minutes or 20 minutes. Otherwise, by the way, you will be able to also book a cab so you can safely reach KL. So that's the early detection is all about. And yeah, so this is another thing. It's again kind of a digital thing. Everything will be available in the dashboard. Yes, you can easily, even it will inform the manufacturer, or it may be informed to the service personnel. So this is what I was talking about. Everything will be like a node. So it's all connected core technology. As we have a systems in our lab connected in a LAN. So that is what which we are planning. And as we have a wireless charging for our mobile in future, there may be a wireless charging for the cars also. It is possible. So that's the power of with this particular process, how it is going to help us in the medical field, healthcare. One of the important and highly valuable process in the world, because matter of human life. That's the reason we are talking about. Again, here, I need not to explain, because we are using the smart watches, health plates, and all these things. Apart from that, how it is going to enhance the process when we do the surgeries, because now we are the augmented reality and augmented technologies, how it is going to help the patient or help the doctor to make the process in live and more precise. That's another important thing which I wanted to highlight. And this is what sorry, yeah, I clicked. Yeah, it's okay. It's okay. Yeah, I'm comfortable. Thank you. So this is another area where I was not talking about. So it's possible to have 24/7 surveillance of a patient, and any disease management. It is possible. And finally, so you need not to go to the hospitals and make the hospital is in a highly crowded one. So early detection. So it will make the doctor will be able to give a suggestions. He can diagnose and he can give the medications accordingly. Even for a small headache, we need not to walk in. We need not to panic, because most of the disease, most of the problems, it will happen because of the panic. So that we can address upon. And moving on, lot of medical devices. As I said, one of the medical devices, this is one, and implantable sensors. Because now I'll tell you, we have a research is going on at our campus, because we have a dental college as well. So we want to do some kind of implantable sensors in teeth itself. So that's again one of the area where we can think about small sensors implantable. So that is, it's possible. So that will make not only for the teeth, it may be for anywhere. So that would be, see, in the future, the sensors will not be there not only in the smart manufacturing, or it may be a car, it would be in the human body as well. So that's the world which we are going to live in. And so the same thing. So we have to analyze a lot of data. We need a lot of, see, now we are talking about GPUs. Probably future it may be any other processor which we have to work on to manage the particular data. And so again, these are three are the important problems which we are coming across in the any IoT related. One is data security, another one is integration complexity and regulatory compliance. And yeah, so one of the another thing which I wanted to highlight today, this telemedicine and AI integration and wearable tech advancements and blockchain adoption. These are the area for again for our research. We are working on it. This particular area, we have signed an MOU with one of the company for it's in a telemedicine company. It's in a, they are into a cold call, and we are also connecting with a hospital probably for the cancer and other related aspects. We are working on it, and this AI integration, this thing we are integrating. We wanted to do it with a small village. It's in a tribal village where the internet and everything is not possible. So at least we wanted to make them to walk into nearby taluk or the capital of the place. So at least that time they will be able to get the data, and that those data will be will be processed by the hospital, and they will be able to identify what type of disease they have and how it can be cured and what would be the medication for that. So that's the plans. And here one of the another thing, because we are talking about when we talk about the human, when we talk about the medical, we want to also talk about ethical practices, because the data of any patient to be maintained safely and the high secure manner. So that is also we are planning, and we are again by adopting the blockchain. Yes, it is possible. And agriculture, yeah. So I don't want to know because here also we are using the drones. So drones, probably most of you are aware. Again, it has a lot of applications. Here we are also using the AI. For we have adopted a new village in nearby in our campus. So where we are using image processing, and we are also using the drones for the agri 2 acres land we are taken from the nearby village, and there our own faculty team from electronics and communication and mechatronics, we are taking the image and regularly monitoring the crop development. And there turmeric is one of the important crop over there. So the growth of the turmeric and particular for each and every time, and how the farming can be done, either it may be a water related or it may be a other process related. So yeah, so one important thing as per the process, we can avoid huge amount of water based on the soil conditions. Based on the water conditions, we can reduce water savings and fertilizers. Yes, that's another important thing which we are talk about. And finally, we'll be able to maintain the sustainability by having the biodiversity preservation and home applications. So finally, this is what I was mentioning about. There are two intelligence, AI and augmented intelligence. Let us work together with the machine and make sure we are able to now do things. This is one of the another thing which we have come across in our country. So the tool name is Anuvadini. Probably you can also try. It is in a tool where it will be able to convert any voice or any document, or it may be a image. Normally, document can be converted, with a different language. But here, you will be also able to convert the voice. Even the live video also can be converted into a different language. It is in a tool from Ministry of Education in our country, anuvadini.ac.india.org. So you will be able to convert text to text, image to text, speech to speech, document translation. Recently, the budget speech of our the finance minister was transferred into different language in live itself. So when she was presenting the budget, so it was people able to see the budget in a different language. That's the great thing which we can use it. So finally, so I wanted to conclude. Let us manage the AI-driven world safely. So that's another important thing which we have to highlight. So thanks for the opportunity to the MAHSA University, and let us celebrate the AI. It won't be a disruptive. It is all about how we are going to use it in a constructive manner. Thank you.
Thank you, Prof, for the insightful speech and sharing file. Next, the second keynote speaker speech is going to be delivered by Yang Berbahagia, Professor Dr. A. Kumaravel, Dean, Administration and International Relations, KS Rangasamy College of Technology. Professor Kumaravel joined in KS Rangasamy College of Technology in 2008 as a head, Department of Mechanical Engineering, and became the Dean, Administration and International Relations in 2023. He has more than 30 years of teaching experience. He is a fellow member of the Institution of Engineers India, a chartered engineer, member of American Society of Mechanical Engineer, and Tribology Society in India. He is currently Executive Committee member of Mechanical Engineering Division in IEI Salem Lokan Center. The topic title that will be delivered is Fuse Deposition Modeling, Effect of Process Parameters on Mechanical, Flexural, and Vibration Damping Properties. Without further ado, please welcome Professor Kumaravel.
So very good morning to all of you. I thank the management of MAHSA University for providing me an opportunity to present the keynote address on the fuse deposition modeling, effect of process parameters on mechanical, flexural, and vibration damping properties. So you may be thinking of this more of IoT machine learning AI we are talking about, and how it is related with the mechanical engineering, and people are wondering about using this AI, IoT and machine learning in the mechanical engineering field, but we should. So these are all the research facilities available in the Department of Mechanical Engineering. This is related with the Center for Manufacturing, Material Processing and Manufacturing, more relevant of the composite materials. Apart from that, the engine performance, the testing of fuels using the engine performance, and so then another field is the welding is the major domain area. These are all the three major domain in the Department of Mechanical Engineering. So this is more relevant with the composite material like metal matrix composites and the natural fiber reinforced composite materials, and the characterization of the natural fibers. And also then I have not put that some of the photos here about the additive manufacturing. We have the two 3D printers are there, and one is like using the PLA material, and then another one is you can use the peak material also to print the 3 products. So this is the project that is the presentation overview, and so maybe introduction about the what is called the industry 4.0 various stages of the industrial evolution. And so we have something like related with the additive manufacturing processes and different methodology, and you have something like a specific domain. I have taken this fusion deposition modeling. There are various topics are there for manufacturing of the various products using the additive manufacturing, and how these processing parameters influencing the mechanical behavior of the materials, and like infill pattern, different type of infill patterns and infill density, and then what are all the process parameters, and what is the effect of process parameters on the mechanical, flexural, and vibration damping characteristics. So this is the introduction part for various stages of the industry revolution. And all we know that now the previous presenter also presented strike out of this 4.0 into the 5.0. So probably we can add the augmented intelligence to the mechanical engineering also, how it can be implemented and how this can be used for the mechanical engineering, particularly in the additive manufacturing process. So how it is connected with the like circular in the early days is, so then we use the material and then throw off once it is used for the purpose, and then it is thrown off. And now people are using and concentrating on the waste to wealth technology, and so then the waste materials can be recycled and utilized for the other purposes. And so it is comes to the circular economy comes into the picture, and by recycling the waste materials. So these are all the different domain related with the industry 4.0, like smart robotics, cyber physical systems, augmented reality, additive manufacturing, cloud computing, and big data modeling and simulation. Here we are talking about the additive manufacturing. So what is the definition for this additive manufacturing? So you can print using the printer, the 3D component, 3D three-dimensional component can be printed using this 3D printer. So by the layer by layer method, that is what we are using in the additive manufacturing processes. And then how this product is developed from the raw material and to the finished product. So then why this topic is coming to this topic, like in the conference, like digital transformation towards the industry 4.0. And here we are using the modeling software and those modeling software into make it as a slices, and those slices can be used for the fusion deposition modeling, and then the finally we'll get the 3D printed product. And so, what is the difference between the conventional machining process and the additive manufacturing process? And we see that first, you can see that here. So, from the bulk material, and then we are getting the final product. You see that the huge amount of wastage in the material, in terms of the material. Okay. So, the second line, that B line, you see that very small material we are using that and then completely utilized, maybe it is a 5% of wastage, and then we are converting this material into the final finished product, and you see that the wastage is minimum. This is what the additive manufacturing concept. So then what is the advantages of the additive manufacturing process? Then there is no design constraints are there. You can eliminate through the modeling software. And also then you can able to produce the complex parts. It may be a small product and can be the complex material be modeled and then entered into the useful the product also can be minimized, and then it is a lot of research is going on in the additive manufacturing processes, so that you can able to then long way we have to go for using this 3D printed product into the reality. But so then the research is initiated, and then the process with the PLA, the people are comfortably utilizing the PLA material and for the various applications, and the metal 3D printing is on the way, then long way we have to go. And so then the post processing time is very huge when compared with the PLA material, and can be overcome with that over the period, so that can be utilized for the 3D printing products. And then there is a flexibility in the design, so you can able to change your the dimensions of the product at any point of time, because we are using the modeling software, and we are not using the in the reality we are making the product and then use it, and then you see that so what is the complexity and what is the error is there, and but before that we can able to model and simulate, and you can able to do that, so that there is no expensive in the tooling requirements, and also you will get the good dimensional accuracy when we are going to use this additive manufacturing process. But in like sometimes you have the challenges also, and that can be overcome by adjusting the process parameters, so that you can able to get the good surface fittings. And then there is a wide range of materials also can be used, like a polymer, metal, ceramics, and it is well suited for the manufacturing of the high value replacement and repair parts, because you take in the industry, and probably then the parts are manufactured in mass production, so then there is a one component failure during the shutdown period in the machine, so that can be replaced immediately, maybe something like 2 or 3 days you can able to the manufacture using the additive manufacturing process, and that can be replaced immediately. So probably sometimes so the lead times or maybe a month to 6 months, and then so during that the shutdown period, so then the cost involved is very huge. So what are all the applications in the additive manufacturing process? These are all some of the applications listed here. So in the automotive industry, and you see that the component, that is a fuel pump or then water pumps, can be fabricated using the additive manufacturing process. And then aerospace industry, you have the turbine blades, gas turbine blades, and then medical field, you have the implants, and then can be the 3D printed using the ceramic materials. So those implants can be used, and then so because you can have the something like an image of the bones, and so through the scanning, through the scanning, and you can able to take the image, and that can be processed, and then that can be modeled into the through the modeling software. Then we can able to make a product. So through the ceramic material, so it will be used in the medical field. And then so jewelry also they are now using nowadays use this 3D printer for creating something like a different patterns of or a different design of the jewelry. And so they are all using the architectural industry also. So now you see that the big house also they can able to print. Then in India, so one library building was 3D printed using this additive manufacturing process. So this is industries using the 3D printing technology. So then what percentage of additive manufacturing technology is used in the industries? Major industries like the machine tools, and next to that it is the motor vehicle, automobile industries, and the aerospace industries, and the remaining fields are the significant numbers in using the additive manufacturing process. So this is the classification of additive manufacturing process. You see that there are different type of the process can be used for making the 3D product, 3D printed product. And so it is basically something like the formation of the product and methodology, what we are using in that. And then the second one is the type of base materials which is used for the additive manufacturing process. And also then you see that the third one is based on the medium, what type of medium used for the additive manufacturing process. Accordingly, then you have the variety of process are there. So we take into this fusion deposition modeling, particularly the effect of process parameters on the 3D printed product. So this is the basic methodology used in the fusion deposition modeling. So you have the wired, the spool is available, and then you have to use these materials maybe based on the number of extruders. You can able to use 2 or 3 like the wired pool, and this is fed into the nozzle like extruder, and there we are maintaining the temperatures, different temperatures. It is based on the type of material. So you see that the PLA material normally we use around 250 degrees centigrade in the extruded temperature, and so the peak material, so then we use 420 degrees centigrade the melting temperature. So in that extruder the materials melted, then it is deposited in the layer by layer method. That is what the basic principle behind the additive manufacturing process in the fusion deposition modeling. And what all the materials can be used in this fusion deposition modeling, like so PLA material, ABS, PET, nylon, TPU, PC. And then what is the advantage of using this, the FDM technology? It is a clean process. It is printed in the closure space, and it is easy to operate because and this model is created using the software and then processed in the various stages. Like after that, we are generating the G code, and then the G code is sent to the 3D printer, and then based on the guidelines in the G, that their extruder movement will be there, then you can able to print the material. So it is easy to operate, and excellent accuracy and repeatability based on the optimization of the process parameters, and it is the dimensional stability is also more. So this is the three different stages. One is design stage, and then manufacturing stage, and the testing stage. This is the major three streamline used in this FDM technology. And so in the stage one, all related with the softwares and the slicing software, design software. It is based on that. So you can able to create the 3D model, okay, and then you can optimize the dimensions of the particular product. So then after that, the manufacturing phase, then during this manufacturing phase, what you have to do is then the 3D model is created in the modeling software like a CATIA or any other modeling software. And the model is converted into the STL file format, and then it will be used in the slicing software, and then it will be sliced. There also you can able to take care of all those process parameters, and you have to repair. So if there is any wrong in process parameters is there, you have to clear it. And then you have to generate the G code, and then it is fed into the 3D printer machine. So then the testing stage, once you get the 3D printed product, so then you can able to test the materials for the application. So then if it is true, yes, then you can use it. Otherwise, you have to do it in the modeling stage itself. You have to correct it, and then you have to model it. So what are all the different infill patterns? This is one of the major parameters which is influencing the material behavior. And so then the different patterns, you can use it. Okay. And so these are all the some various pattern type is there, and we can use it. And then each time you can able to print the 3D printed material, maybe the specimen material, using the different infill pattern, and you test for the properties like the mechanical properties, flexural properties, and the vibrational characteristics. And then you can see that what kind of the behavior within the materials. Because why we go for the additive manufacturing process? So initially, what we use is the conventional material, like the you take that steel isotropic material, and you can have something like a standard materials are there. So then with that, the standard material properties. If I want to tailor something like properties based on my applications, and then there is no opportunity for that. Then now after that, what happened is the people are using the composite materials to tailor the material properties. So there, what they will do is they will combine two materials based on their applications, and they will get the material property, they can use it. And also they able to reduce the weight of the materials. So wherever it is applicable, those materials are used for the better performance the material. So after that, what happened is the additive manufacturing comes into the picture now. So in the additive manufacturing process, even more category of the material, that is the properties you can able to make it. Because in the composite materials, you cannot able to create these kind of patterns while manufacturing, because the manufacturing of composite material itself, it is a complicated process. And so by that is incorporating these kind of inbuilt pattern it is very difficult. But you can use these pattern type of the materials, then infill materials, you can able to achieve through the additive manufacturing process. So this is the infill density. Like you see that the first one is 100%. That means you don't have that is the porosity is very less. After that, you see that the infill density 90%, 80%, 70%, 60% like that. Then you have the hollow space in the 0%. Okay. So you see that how much variety of you while using this infill density itself. Okay, so the even if the step size is 1%, the 100 types of different material behavior you can able to get with only the infill density. Then after that, you have the different type of pattern. Infill patterns are there, and based on the temperature, bed temperature, and then extruded temperature. So every this process parameter is influencing on the material behavior of the products. So we can able to get more number of the optimized material parameters than properties. So for based on the particular like the process parameters, why we want to optimize the process parameters, then we want to have something like a that is material behavior, right? So so what is the role of this? Okay, process parameters, and then you have something like a physical behavior, you can able to change it, and the part strength you can able to based on the material property you can change, and the surface quality of the material also you can able to optimize it, and you can get the accurateness. Okay, the dimensional accurateness also it is based on the structures also it is a matter, and so then we have to take care of the particular application. These parameters apart from that maybe this, but the major parameters are listed here. So these are all the list of process parameters like layer thickness, model build temperature, infill pattern, infill density, raster width, and then raster air gap, and then cell thickness, raster angle, build orientation. So this layer thickness and the build temperature, infill density, infill pattern, and the build orientation. These are all the major parameters which is involved in the significant changes in the material properties. Okay, so in composite material, you have only the properties of two different materials and the orientation of the reinforcement. Okay, so these are all only the major parameters, only 3 to 4 parameters involved in that. But here, then based on the application, you can change and then you can get the variety of the material behavior based on the variety of the altering the process parameters. Okay. So here, so what is this major rest triangle? So this is the rest triangle, and it is varying from 0 to 90 degree. And you see that this is the layer thickness. So each and every layer, it is printed layer by layer method. The thickness is the major parameter, and the built orientation. Okay, so these are all the major which is significant, that is altering the material property significantly. Okay, so next one. So these are all the printing parameters. Like, so normally we use these values like bed temperature is 60 degrees centigrade, nozzle temperature is 220 degrees centigrade for the PLA material, and the printing speed is normally 20, and based on that you can alter this printing speed, and then the density is 50%, layer thickness 0.2, overlap is 15%. This is something like to edges, you can meeting to one layer to the another layer. There is the you can also alter the value of this overlap based on the applications. Okay, so here the terminology is given. So what is the gap and then what is the thickness, like that. What is the thickness of the layer, and you see that. So this is the tab which is used in the slicing software. There you can vary the process parameters and then you can print that. So now we see that what is the effect of process parameters on the mechanical and flexural vibration characteristics. You see that the alpha is the airstrike load, so 0 to 90 degree in the step size of 15, and here 0, 30, 45, 60, and 90. And you see that the plot is stress strain plot is plotted based on the values. Okay, so this stress strain plot will give the behavior of the material. Okay, so during the linear region and also the non-linear region. And so you see that when you use the 0 degree, you have the higher lower strength. Okay, and then when you use the 90 degree, then you have the higher value, strength value. So in between, when you are going to use the 30 degree, 45 degree, accordingly it will change. And you see that there is a brittle in nature in the fracture period. Okay, so fracture point. So before that, you have the linear region, which is behaving like the different stages. Okay, for the different orientation, rest triangle, and you see that the degree alpha value and the Young's modulus value, the behavior of the material, Young's modulus value, and also the strength. Okay. So printing parameters which is used for this sample for plotting this graph is like layer thickness is 0.2 meter, extruder 0.4 meter, and then printing speed 30 millimeter per second, infill density 100 percentage. You can use the various infill density so that you can able to plot the graph, and you see that the how the material is behaving for the various infill density, and also you keep all these constants are that is parameters are constant. You can vary one parameter, so then you can see the behavior of the material. Okay. And so these are all the three different type of the loading and the build directions. One is the flat, one edge, and then this is upright. This is also you can able to alter, and you can use a different the printing build direct orientation. And you can see the material behavior in the 3D printed product. Okay, so it is shown that it is a brittle failure. Okay, so during this, when you are going to apply the load, okay. So what is the effect of flat, on edge, and upright orientation 3D printing product? You see that the higher strength is in the on edge, and the flat, this lower, and upright it is more brittle than the other two printing. So each and every parameters it is influencing on the material behavior and also the material in nature, whether it is more brittle or less brittle. So here you see that the what is called a stress strain curve for the rest direction angle, that is a rest angle. And so 0 to 45 degree, it is having a low strength and also then the more brittle. And you see that 90 degrees more strength, and also then the brittle in nature is less when compared with the 0 to 45 degree. Okay, so it is the value for the different patterns like a rest triangle. So this is for the layer thickness. Now you can alter the layer thickness and you see that the behavior of the material. And printing temperature. Next, how the printing temperature is affecting on the material properties on the Young's modulus. You see, this is for the various printing temperature like 180 degree, 200 degree, 220 degree. And then what is the corresponding Young's modulus value? And you see that when you use the lesser printing temperature, then the Young's modulus value is lesser. And you see that the 200 degree, 220 degree centigrade, you have the higher value. Okay. But when you see that the different rest triangle, Okay, 0 degree, 45 degree, and 90 degree. So in 90 degree with the 90 degree raster triangle and the 220 degrees and printing temperature, and you have the more strength when compared with the other one. Okay, so and you see that the lower value is in the 0 degree with 180 degree printing temperature. So both raster triangle and the printing temperature influencing on the Young's modulus value. Okay, and this is like the ultimate tensile strength. You see that with the different raster triangle with different printing temperature. Here also you can observe the different values of the ultimate tensile strength. Here also then normally we can observe always 90 degree with the higher printing temperature is giving more strength when compared with the other parameters. And this is the different type of infill patterns, and here it is taken as 1 and 3 perimeter cell. Okay, and so here 1 perimeter cell, this is 3 perimeter cell. So this 3 perimeter cell which is achieved by using the double extruder, so you can able to do that. Okay, so you can print with the different patterns, and these are all the material behavior. So you have something like stress strain curve for that hexagonal infill pattern. Okay, and you see that the rupture, that is continuous loading, then there is a breaking point. So how the material is behaving, like you see. And so this is like what is called this is edge-wise loading and the flat-wise loading, and you have the more strength on the edge-wise, that is the flat-wise loading and compared with the edge-wise loading. So this is the, and also you see that there is a staircase behavior in the material. Okay, so this is due to the behavior in the what is called hexagonal infill pattern. So this pattern of the staircase pattern also will vary for when you are going to use the different type of infill patterns. So this is a triangular infill pattern. You see that behavior, and the flexural stress. This is the engineering stress. Okay, and square infill pattern and square diagonal infill pattern. You see that the fracture of the material, how it is fractured after the continuous loading, that is in the universal testing machine. So this is a cross infill pattern. This is the material that is a dimensions for printing. The literature is taken by these authors. Okay, and you see that variety of pattern: 0 degree and 20 degree, 40 degree infill density, 60 degree, 80 degree, and 100 percentage. Okay, and this is the grid infill pattern with 0%, 20, 40, 60, 80, 100%. And so average weight of the specimens when we compare with the cross, grid, and the triangular trihexagon, and you see that infill ratio is 100, and then you have the weight, more weight when compared with the other infill ratio. This already we know that, because obviously when you use the 100% infill density, automatically can able to get the weight of the sample is more. But how it is behaving? Okay, so what is the difference in weight when you are going to use the different infill ratio of percentage? Okay. This is like when you are going to conduct the bending, that is a tensile testing of the particular specimen with the different infill percentage, density percentage, and how it is behaving. Okay, so based on the load and the displacement. Next. So this is the damping ratio of and infill ratio between the behavior based on this damping ratio and infill ratio. You see that the three different infill pattern like a cross and a grid trihexagon, and then infill ratio varying from 0 to 100, and then damping ratio value. These are all the values. You use the cross infill pattern, you see that the higher damping ratio, and then it is lower for the trihexagon with the infill ratio is 60 percentage. Okay, so this is the minimum. So the maximum when you are going to use infill ratio is 40 percentage. So this is the in between behavior of the material. Okay. So here what we are doing is you prepare the sample and then one end is fixed, the other end is placed to the accelerometer. You can get the data from that and you can able to identify these damping ratio values. So maybe give some excitation on the specimen, loading specimen, that you can get the that is parameters. This is like the relation between the natural frequency and infill ratio. And you see that infill ratio varies between 0 to 100. And then what is the natural frequency value for the respective, the infill ratio with the different, the infill pattern. Okay. So this is the sandwich structures, PLA, ABS, and then combined together. And these are all the material behavior stress strain curve. Okay. And so this is the stress value. You see that with the PLA alone, PLA, ABS, PLA, and then combination of ABS, PLA, ABS. Okay. So here in the middle, you have the ABS value. Here in the middle, PLA. So what is the ultimate strength value? So thank you very much. And so how this additive manufacturing process can be integrated with the AIoT or IoT, artificial intelligence and machine learning. So when I show a lot of the graphs are there. So every graph have the lot of data. Okay, so probably when you are plotting the curve, when you are going to get the smooth curve, so then the data generated is more. And also when you look at it, the CNC machines, because the basic principle here is G code, then the whatever the CNC machine tool we are using, that concept, same concept is used here. And there also each and every moment there is a sensor is placed and then lot of the data is generated. All these generated data is now not processed. It is kept in the raw data. Okay, so those data can be taken and then maybe processed, and then we have to use it as a meaningful the values for these numbers. That is what we have to integrate with the IoT and the AML. Okay, so and also then when you are going to have something like a data, and then you can train the data and you can able to predict. So this much the printing temperature value and this is density it is a future of the research area. Okay, so we have to work on that because only the few researchers are working on this kind of research work. And then we have to inculcate and then implement all those the AML into the material science. Okay, so that you can able to get the different optimized material behavior for the various applications. So with this, I'll wind up this keynote session. Thank you very much for given this opportunity. If you have any clarifications, then I'm happy to answer for you.
Thank you, Prof, for the insightful sharing and knowledge. We have announcement. Dear participants, for those who still not submit the slide presentation, please submit to email MAHSA@mahsa.edu by before 2 p.m. Thank you. Next, we have reached to our last keynote sessions. The last keynote sessions is going to be delivered by TS Dr. Chua Wenshan, Head of Malaysian Smart Factory 4.0 Selangor Human Resource Development Center. TS Dr. Chua Wenshan is currently the Head of Malaysian Smart Factory 4.0 under the Selangor Human Resource Development Center SHRDC. He obtained his PhD in Control System Engineering and Bachelor Engineering in Mechatronics Engineering from Monash University, Malaysia. His key area of expertise lies mainly in the area of control and automation system, fault detection and identification (FDI), and predictive maintenance strategies, which are widely used in Industry 4.0 applications. The topic title that we've delivered is Industry 4.x and Sustainable Smart Factory, a practical approach towards a sustainable digital transformation. Without further ado, please welcome TS Dr. Chua Wenshan to the stage.
All right. Good morning, everyone. Right. While we wait for the slides to come up, right. So my name is Dr. Chua, and I represent the Selangor Human Resource Development Center, SHRDC in short, as the head of Malaysian Smart Factory 4.0. Smart Factory, what we do is we focus a lot on developing new and emerging technologies, and all those new and emerging technologies will then be translated into programs where the community will actually learn to grow together. All right, so I think my slide should be coming up very, very soon, hopefully. Everyone here are engineering students, lecturers from the engineering faculty. Okay, good. So it's relevant then. Okay. Boleh. Is it coming up? Okay. All right. So this is the pointer. Okay. All right. Great. The slides are up. Okay. So the topic title today on Industry 4.X and Sustainable Smart Factory. Right now, of course, when I submitted this title to Dr. Rosie, he's asking me, is it really correct Industry 4.X? Right? People always say Industry 4.0, Industry 3.0, 2.0. Now, why I selected Industry 4.X is because as technology progresses, right, Industry 4.0 is not a new thing anymore, right? It's actually been around for many, many years, right? If you compare with Germany, Germany started Industry 4.0 discussion since 2011. Okay, right now we are already in 2024, so we are already 13 years into this Industry 4.0 concepts, right? Malaysia started Industry 4.0 discussions back in 2018, right? But as technology progresses so fast today, we are now in also another new era of AI, right? But we can't really say that we are Industry 5 because that's not a totally new revolution, right? So we are in between. So therefore, I term it Industry 4.X, all right? And of course, in this era of day, we cannot run away from the term sustainability, right? And how we need to be developing technology, integrating technology towards what we call as a sustainable smart factory, okay? Right, so when we talk about Industry 4.0, right, generally we look at a journey of transformation. So every revolution is a form of transformation in the community. So if you look at Industry 1.0, we talk about mechanization, right? That was very, very long back then. And then Industry 2.0, that's when you have the mass production coming into play, right? When you have large capacity kind of productions, every product is the same for everyone, right? Then Industry 3.0, people talk about automation. So people talk about control systems, automation, computerization. That was a different era altogether already. Now, Industry 4.0 does not really talk about automation anymore, right? It talks about what we call as autonomous systems and how we utilize data to actually create value for a particular production process. So it's no longer just about going into a factory and seeing robots doing everything, right? Because not every factory can be automated. Okay, if you think about a country like Switzerland, right? So Switzerland, they what are their products? They are actually small companies, right? They manufacture chocolates. That's Swiss chocolates. I think you should know. But what are the highest value products that they make? Watches, right? Omega, Swatch, Rolex, right? They make watches. And watches the manufacturing of watches be highly automated? No, it's not really highly automated. It still requires very, very skilled craftsmanship to make a watch. That's why it's very, very expensive. Now, then you talk about concepts of what we call as human by day, robot by night. Right? So it's not really fully automated. You still need the human factor into it. But how do you utilize data to actually create that kind of productivity improvement for your manufacturing industry? Now, why data is so important, right, in today's era? It's because data provides you with information, data provides you with knowledge, and of course, eventually creating wisdom for your manufacturing, right? With the immense amount of data that you have, that's where you can really understand what is actually happening in your production floor, right? You can't do predictive analytics without data, right? And there are many industries that have the misconception that, oh, I buy a software, it can do predictive maintenance. Definitely my company will be thriving from here. But if you don't have data on your own production, right, you don't understand the trend of what's going on, you can never achieve that kind of AI capability to do that kind of predictive analytics, right? But then again, there are also newer technologies coming up, which I will share with you in a short while, right? So how does data drive productivity in a particular manufacturing industry? Okay, so usually when we talk to manufacturers, right, it's very difficult to tell them that, hey, going into Industry 4.0, having data visualization, having a dashboard that will tell you what's happening will provide a better ROI for your company or provide better profitability for your company. It's very difficult to convince local manufacturers about that, because to them is, when they want to see results, it has to be instantaneous, right? So how data actually helps to improve productivity depends a lot on both the digitalization factor, but also comes back to the human factor, right? For example, right, if you look at this chart here, okay, what is the only constant in a day that we have? Anyone? What's the only constant in a day that we have? Time. 24 hours in a day. Anyone got 36 hours? Or you can time travel? Not yet, right? So we all have only 24 hours of time in a day. Production also has the same, right? So what do you do with these 24 hours in a day will be the determining factor of how productive you are or how efficient you are in your manufacturing, right? So if in a point of time in a day, something happens and you can't be productive because you need to fix something, right? So that's what we call as downtime, right? Machine downtime. Something happens to your machine, it goes down, right? Then you need to fix it. So when the machine goes down, you don't have production. It's not producing parts, right? Therefore, what happens if you're not producing parts? You're wasting time, right? So that's where cost of wastage increases, right? So every point here is a point of time where you can see wastages. For example, if your machine is down, something happened, how fast do you know about that incident? 1 hour later? Or do you know it immediately from your mobile phone? Okay? So that is what we call as time delay, right? Secondly, if you know that something happened, you need to troubleshoot what's happening. If you are new to the company, maybe you need some time or more time, maybe 1 hour to troubleshoot. If you are actually someone seasoned in the company, you can go next to a machine, hear it, and then you know, oh, that's where the problem is. So this is where we call it analysis delay. How long do you need to troubleshoot a problem? Now, after you troubleshoot a problem, there is also something called a decision-making process, right? Now, sometimes we make decisions very long, right? Okay, we take a lot of time to make decisions because everyone cannot agree to a particular place. right? So one relatable example is, right, when you want to go for lunch with your friends or your colleagues, you ask what to have for lunch today. Anything, right? Anything, anywhere, whatever, right? So then this goes into a circle again, and you just wasted 20 minutes of your time thinking what to eat, right? So same thing for manufacturing, right? I think this is the problem. No, I think this is the one. No, I think this is the one. So it takes time to make a decision. So the decision making process is long, then you waste time. Okay. Now the last part of it is taking an action, right? If you can take an action immediately, if you have the spare parts, you have the equipment, you can do it straight away. But if you don't, that's where you lost time again. So this is how manufacturers unintentionally lost time, right? And therefore they actually wasted a lot of opportunities and a lot of productivity time, right? So how does digitalization then help them to minimize that kind of time, right? If you have real-time capability of your productivity, your production, you can see it straight away on your dashboards. You can see it straight away on your mobile phones, right? You can make a decision directly with, your right predictive analytics algorithms, right? You can have proper decision support systems. Basically, you have very, very minimal wasted time. I won't say you have zero waste of time, because sometimes you can't go zero waste, but you minimize it to the bare minimum, right? So this is what we are trying to achieve in terms of Industry 4.0. Okay, right? So I like to ask this question to manufacturers in Malaysia, because this is actually something where most Malaysian manufacturers will relate on. When I ask them, how far do you think that we have gone in terms of our digital transformation journey? Okay, so I asked Malaysian manufacturers, they can't answer. I asked government agencies, they say, oh, we have done A, B, C, D, E, F, G. But I asked, how about the outcome? How many companies in Malaysia actually started their journey, digitalized their plant, and really on the road towards a smart factory, right? So I think the answer is they are doing a very good job in terms of their automation. Vietnam also is another industrial zone that they really push very, very hard. Our another neighbor, Indonesia, also has good policies in place. But why Malaysia is still needing that bigger push to go forward, right? So one of the key problems when we talk to many Malaysian manufacturers or industry is that they know the benefits of it, they know the advantages of it, but they really don't know where to start. Okay, that's one factor. Second factor is that they know that there are technologies available, right? That are out there, but they don't know how can it be applied for a specific sector. So Malaysia is very diverse in industrial sectors. So you have food and beverage, you have aerospace, automotive industries, furniture industries, plastic manufacturers, rubber product manufacturers, rubber glove manufacturers. What else? A lot, right? A lot of different manufacturers. Cosmetics, that's another manufacturer in Malaysia, right? So we have so much diversity in manufacturing, right? And one of the key problems that they now face is when it comes to Industry 4 is technical manpower. They're looking for people, right? They can't find the right candidates to support them in their process. Number two is that they lack technology know-how, how things work, right? There has been a lot of dependency on companies in Malaysia buying technology and not building technology. So this is something where we are trying to change that, but it takes a while. And of course, the third part of it is cost, right? So a lot of manufacturers think that Industry 4.0 is expensive, right? It's very costly to start. But I will share with you how it is actually not expensive to start. And even as a university, as students, you can actually access this technology very, very easily on your own. Okay? Right. So what is a smart factory? A smart factory basically consists of 3 areas, right? You have your operational technologies, right? That's where your hardware software integration comes in. Okay? Your information systems and technology, that's where your data is then sent to databases, okay, or data sources, and it becomes a big data pool where you have all your data in one space. You can visualize it, you can do your analytics, you can do your AI on your data, and then that's where it creates a value for you. But this is where the next value comes in, which is what we call as the digital factory. So the digital factory is where eventually manufacturers can make digital twins of their factory, and that's where the real process optimization comes in. Okay. Now, when we look at technology, when we want to implement technology, it must be modular, flexible, compatible, and scalable. Now, why these are very, very important? Okay. Manufacturers tend to buy software or hardware and they don't think about the next step. Okay. What I mean by that is basically they buy a software platform. It does brilliant things, but they forget that you need to still connect to the rest of the machines and the systems. So a lot of problems happen when your software or hardware cannot link to different systems, right? So linking to systems or system integration is very, very important or key in Industry 4, because if you can't link them together, what happens is that you don't have holistic data integration, right? So everything is in like bits and pieces. You have to open this software, open that software, open that software, open that software. Then you have one guy going to this particular software, download the Excel sheet, put the Excel sheet in another platform. So this becomes a very, very hectic process, right? You actually spend more time fixing that problem rather than fixing other productivity problems, right? So what we need to always look at is the capability of any hardware or software to be modular, scalable, flexible, and compatible. Meaning to say that if I were to need to link to things later on, I can do it with minimal intervention or minimal cost, because that's a very, very key important factor, right? Imagine if you implement a software and you want to link to another system, you have to pay another 10,000 ringgit. Link to another system, another 10,000, another 10,000, another 10,000. It's never ending, right? So understanding that will be very, very important for you. So how we move the companies forward is we look at a concept where it is brand neutral. That means you don't have a single brand that you support, right? So in a manufacturing production line, you can have multiple brands, right? You can have a Omron, Siemens, Mitsubishi, Beckhoff, Wago, Keyence, right? These are some brands that are quite well known, right? But of course, you need to be able to link them together. And how you link them together is what we call as open protocols, right? So every machine can talk to each other in a standard language. For example, today we are speaking in English. It's a standard language. Bahasa Malaysia is a standard language, right? The national language of India is a national language. But you also have closed protocols, which are what we call as dialects, right? For example, your own community have your own dialect, right? That is basically closed protocols, right? You don't have an open standard to it, okay? Now, open collaboration is also an area where companies and students, lecturers, community, researchers, this is really where that ecosystem of collaboration can come in, right? When we talk about open collaboration, we mean that basically technologies are now being more and more scalable, more and more affordable, and more open for accessibility. Now, think about this. ChatGPT was launched. Everyone knows ChatGPT, I'm sure, right? That's like the biggest, right, hype and buzzword, right? So when ChatGPT was launched, right, their own version of an open AI model. So this is where open collaboration comes in, because ChatGPT or OpenAI is a closed protocol, is a closed network. Data is not privatized. So then people think, okay, I want to make AI available for all. So this is where collaboration comes in, right? And that's where we call it the open source community movement is something where we see greater value actually coming up, right? Now, the next part of it is rapid prototyping. Now, we're not talking about rapid prototyping in terms of 3D printing, right? You just heard a very good talk, a very good lecture about 3D printing. But when we talk about rapid prototyping here is how fast do you develop a software that works? Functionality over aesthetics, right? Can you do it in the fastest time possible, right? So I watched a video many years back about these two personnel. They are comparing between a person that uses very heavy coding to code a website from A to Z versus someone who uses a rapid prototyping tool to build a website from A to Z. Okay, so I guess you can see that the person that started from zero, right, took about more than 7 days to finish a website. Okay, that function. The person with zero programming background uses what we call as low code technologies, right, is able to do it in 3 days. That's how we want to change the way people work, right? We call this a citizen developer concept, right? That's where rapid prototyping comes in. Why you want to go there? Because time is a factor. The more time you spend to build something, the more money you spend, the more resources you spend, the more time it takes to give a company that impact that they want, right? So this is where we talk about reducing the time to deploy. So when we talk about integration of a smart factory, right, it's really about understanding how things connect, right? So a lot of times, people think that, integrating a smart factory is very, very difficult. We don't know how to start and all that. What I always say is start by understanding how things connect, right? Because the moment that you understand how it connects, how the connection is made, you are 80% already there, right? Because you know how devices talk to each other and all of them are more or less the same, okay? So if you know how to connect vertically and horizontally across the automation pyramid, it's actually very, very straightforward on how you actually can move into a smart factory, okay? Right? So yeah, moving from the vertical side all the way from your shop floor to your enterprise resource planning or horizontal between devices, okay? So a question that I always ask is, can you really achieve manufacturing intelligence through just having bots or ERP software, right? Because that's what usually most Malaysian companies would do, right? But I always tell them that that's not the key factor to it, okay? So how do we build a smart factory, right? And it's actually not very complicated. If you look at this diagram over here, I show it as a topology on how you can actually connect things from the shop floor level all the way to the ERP level, right? So from the shop floor level, most companies will have two options, right? You have a machine. Now, if you have a machine and if you can link directly to your controller, that means you have access to the programming codes. Basically, it's very easy to connect. So you just have to put a gateway. We call it a gateway, IoT gateway. You connect it to the machine, and then you use a software called Node-RED to pull the data from the machine. Okay, so that's what we call as a system integration step. So you can use Node-RED to read and write to the controller because you have access to the controller. Now, what if there are industries that I have a machine that is older than me, 30 over years old, 40 over years old machine, still running, still working well, still churning results, right? So if for students, if you go to a factory, right, you will see machines that are older than you, okay? Now, those machines then, question is, they are definitely not Industry 4.0 ready machines or ready to be integrated to Industry 4. So what we do is we talk about digital retrofitting, right? So You will retrofit the machine. You will gather data through understanding the machine operations and pulling the data that you need. This is what we call as digital retrofitting. Okay, using sensors, using your gateway. So once all your data you have collected, right, eventually what happens next is that you need to push it to a dashboard software, right? So you push it to a database, right? It can be MySQL, it can be a MySQL database, MS SQL, PostgreSQL, doesn't matter, right? Then you visualize it on the dashboard. So that's where you have a centralized module controller. You have your Grafana. So Grafana is like a dashboard visualization software, right? Then in terms of your ERP systems, you can use systems like ERP Next, right? ERP Next as a ERP or a manufacturing execution system, right? Then as you go into bigger data analytics, that's where you have your big data using Spark. 9 is actually your data analytics software, your machine learning, your deep learning, right? Later I'll show you that you don't need to know Python extensively to actually do machine learning, okay? Then you can have Frapple for production planning and scheduling software, and then visual components in your digital factory, right? And of course, cybersecurity, you can look at softwares like Wazoo, OpenSense, and many, many others. So when I show a manufacturer this particular chart, right, very often people will ask me, how much does it take to build a smart factory? Looks like there's a lot of software, hardware that I need to invest in here. So I would tell manufacturers that if you look at this chart here and you count the number of software platforms that you see, there's only one software out of everything here that you need to pay. Everything else are available for you to use, to download and explore. So this already brings down the manufacturing, the Industry 4.0 implementation cost to the very bare minimum, right? So this is why I say Industry 4.0 is not expensive to start, but you need to really know how to architect your system properly, right? Architecting a system means you need to know how devices connect, how systems connect, and nowadays it's actually not difficult because with the ever increasing line of technology and with the vast amount of resources that you can see online and with the availability of good education programs in your universities and also in centers like us, you will know how things connect to each other easily, right? So at the shop floor level, understanding the communication protocols are important, right? Your Modbus, MQTT, OPC, these are some examples of communication protocols, right? Moving up, then you have your REST API, Kafka, in kind of integrations, right? So usually in universities, maybe you might or might not cover this because it is actually quite a big scope, right? And usually it's good thing to cover when you start to go towards your practical work experience or your industrial training experience, right? So a lot of my interns actually work on this kind of setup, okay? So once you understand how things connect, once you understand how things are linked together, right, it is actually very, very straightforward to start building a smart factory, okay? So usually when we go to companies, right, we will say that, okay, let's take a ballpark figure. Let's say we say 20,000, right? 20,000 ringgit, or 20,000 ringgit is now, USD is actually quite high now. In terms of ringgit conversion, it's what, 4.6, 4.7 now, almost 5. Let's take it at 5, right? 4,000 USD. That sounds like a very small number to a lot of people, right? Okay, let's say I want to digitize. What can I do with 4,000 USD? Okay, I can do, right? I can go up to it's really how you architect it. It's really how you understand the technology behind how things are linked together, right? Because once you have the data, once you have the right architecture in place, it's actually very, very easy to scale. Yeah, so this is how we help companies to start visualizing it. 20,000 is actually a very high ballpark figure. For example, I had a company, a manufacturing, automotive manufacturing production line, right? They really understand how things connect. So they then found a better way to save money, right? So they retrofitted an entire production line, okay? An entire production line. So you have 11 or 12 machines in one production line. So they just bought one single hardware, which can cater for the number of signals that they need. They connected all the signals together. They retrofitted all their production machines. So they only spent 10,000 ringgit for one production line. And that's already a high figure. 10,000 ringgit, which is equivalent to 2,000 USD. So you can see how technology is not expensive. It's really how you know how to architect to make it work for you, right? So we go with companies with a level of maturity. Now, why I always like to put this up is because still remember one of the very early events that I attended on this digital transformation. It was actually a seminar or workshop by a Microsoft provider. Okay, so Microsoft, well, basically you have everything. That's why they call it Microsoft 365, right? Basically, it's one whole circle. So the whole idea of the Microsoft sharing their technology is that, okay, we can help you to integrate your processes from the moment you get an email to doing this, to doing that, to doing this, doing that. So then Microsoft suddenly say that, we have an AI builder. Okay, so back then, this was 4 years ago. We have an AI builder. Okay, so then I asked that one company personnel that was sitting next to me during the session, what do you think about Microsoft product? They are sharing, oh, fantastic. They have an AI builder. It can solve everything in my production. So I then asked one question. How about the data? Where do you think the data is going to get? Oh, Microsoft will handle for me everything. Actually, that's wrong. Microsoft doesn't handle any kind of data integration from your factory. They only handle data that is in their platform called Azure. So the link from shop floor to Azure is another part that they never considered, right? So this is why understanding the data automation maturity is important. First, you need to collect data, right? How you generate data. And that's not by writing down on a piece of paper, writing down on a laminated sheet, and then, calculate your data. That's not the right way, right? What we want to do is we want to digitize that production, right? Then you want to visualize it. You want to actually see the data live in your dashboards, right? Then you talk about data storage. You seeing it live, but you don't store the data. You don't know your history, right? You don't know what happened 1 week ago, 1 month ago. You need to be able to see the trends, right? Then you formulate your data to give you some kind of results that you want to see, right? So most manufacturers will talk about overall equipment efficiency, overall productivity. So those are things that we will see. Then only you talk about analytics. Then only you talk about AI. So there are the right stages in place to implement something like this, right? Okay, so this is stage by stage. And so some examples of how things can be done is, if you have a machine, for example, you have a machine with a conveyor belt, with sensors, with touch buttons. It's very common setup for a machine. Okay, very, very common. Okay, so question is what kind of signals that you want to collect. So once you identify what kind of signals, then the next step is to easily identify what kind of hardware to collect those signals. So if you are in this field long enough, you would really know what kind of hardware would suit your capabilities that you want. So, like for example, for a gateway, you can choose any brand. It usually doesn't matter. But really understanding, like, okay, how many inputs do you need? How many outputs do you need? This gateway, what kind of protocols that you need to use? Is it Modbus TCP? Is it Modbus RTU? Is it RS485, RS232? So these are questions that you always have along the way. And this is really not a novel kind of research, but it's really something that you would look at it when you start to apply things. So that's why we always talk about application-based R&D, right? Whereas universities will usually do more novel R&D, right? So you can think about the different hardware that you need, whether it is digital or analog inputs, right? Then if you want something a bit more smart sensor technology, that's where IO-Link technologies will come in. So you have your hardware. Now let's talk about your software, right? So what you want to do is you want to build something. Hey, stop moving. Right? Oh, the video doesn't play. Is it? Oh, okay, it doesn't play from there. Does the video play? There's a video embedded in the slide. Yep. Unless it doesn't play. Uh-oh. Uh-oh. So basically, there's a video that I can show you something moving. So that's usually usually there's no sounds, but those are videos of things moving usually. Okay. So, never mind. I guess I'll just skip to, where's the slides there? Because he didn't download it, so that's, yeah. Okay, we can go to the slide. I guess we can go straight to the slide that I went to just now. Okay. Down. Okay, let's go to this. This one, yeah. Okay. So, okay, the GIFs play, but not the main videos. So basically, the whole idea is how you can use technology that are easy for you to integrate. Okay. Well, internet connection is also one problem sometimes. Okay, this is also a good example that I can share. Many companies in Malaysia, they started off by buying a lot of cloud software. Okay, because cloud software usually are cheap. Okay, because it can do in bulk. Okay, now the problem with that is when a company buys the cloud software, okay, remember that their factories may not have the best internet connection. What do you, before my slide loading, you see a loading screen, right? So they also see that circle going around and around and around and around. They want to run their dashboards. True story, okay? Now, so what I'm trying to show here is how easy it is to go connect your machines. So you have your hardware, your software is a drag and drop, okay? And then you can push it to a visualization software. So that's how easy it is to link your machines, right? Oh, doesn't go to the next screen. It doesn't go next. Oh, okay. Does it go next? Okay. So then when you have one machine, you have two machines, three machines, then you can scale up your machine monitoring systems as well. Okay. Well, there's supposed to be a video here, but I think it's okay. We'll just move on to the next one since I have less time. Oh, can play. Okay. So this is also some dashboards that you can make, right? These are some of the examples. Okay. And these are things that you can build almost easily with your technology that you want to do. ERP-based software, these are something that you can actually use and explore as well, right? So these are something where you can run in your production line. So this is for analytics. This is if you want to run your machine learning, deep learning, you can actually use drag and drop software for analytics. Vision inspection, right? Basically, you have a software that you can do vision inspection. So you can actually utilize that technology to actually run vision inspection algorithms as well. Okay. This one is actually quite interesting. I don't know if you can play this video. Can you? Okay. You can just click right. Now this one is actually quite interesting. This is actually what we call as the digital twin or the digital factory. So in a particular production facility, you may actually want to see how to design your factory, right? So you can actually use a 3D simulation software to actually plot your factories, and you can actually run them. So this is actually quite useful for universities, because if you teach manufacturing, sometimes it's hard to go to an actual factory. You can actually build a digital factory and then teach your students how to actually optimize the production line, right? Is it through having more robots, less robots? How do you optimize the layout? So these are things that you can teach in manufacturing practices, for example. Okay, so this is a software called Visual Components. This is something that we use to teach digital factory, right? This is actually, if you can play the video, this is actually digital twin software. So let's say you have your PLC programming classes. I think some of you have. Okay, it's expensive to buy many machines. Okay, so what you can do is you can actually run your own digital simulation, right? So you can actually build your own machines and program it, in the digital world. So this is what we call as digital twinning, right? So this is integrating your PLC programming software, and this software called RoboDK. RoboDK is actually for robotic simulation with Simumatic. So these are the three software plugged together. So you can see how these three integrate together and then form a manufacturing simulation. Okay, next one. Yeah. Oh, there's the next slide. Next one. Okay, this is one. Oh, it's okay. Yeah, that might, you can. Yeah, this is also another example of, like, you can simulate a filling tank kind of example, and then you can actually use it to build your own human machine interface. Yeah, so this is another example of digital twin. Let's go to the next one. Next slide. Now, I want to show you something a bit more interesting also. Now, you know about ChatGPT, right? Now, can you build your own GPT? Right? So this is an example of how we teach people how to build their own ChatGPT. So you can build it, you can actually link it to your own documents, link it to your own database, link it to your own data sources. This is a software called LangFlow, right? Basically, you're building your own GPT in your PC, right? So you can access your documents, you can access your data sources. It's like building your own AI assistant, right? So you can actually upload a lecture note, right, or a lecture manual, and you can ask questions based on the lecture manual. This is one example of your PDF loaders, right? Okay, next slide. So then you have also examples where this is an example of a PDF loader, right? So you extract your PDF file. This one is an extract of a data. So usually when you have a database, it's very hard to query a database because you don't know the query language. Right now, you can actually ask questions about your database, right? How many tables are there in the database? And automatically the GPT will provide for you that information, right? And it's actually fairly fast, right? And the GPT, the brain of it is not even using the OpenAI models. It's using your open source models, right? That is locally hosted on your PC. Right, so basically, this ensures very good data privacy, right? Okay, next slide. About oh, doesn't go to the next one. Is it next? Press the next. Okay. So if you look at this video, let's say you want to do a course comparison. Is engineering better than IT? For example, you can actually put that course comparison details, right? And you can actually get the students to ask a question about course, right? Let's say I want to know which course is more has more programming inside, which one has more hands-on inside. So this one is an example of a car comparison between Vios and Honda City, I think. Mazda. Oh, okay, Vios and Mazda. So you actually ask a question between Vios and Mazda. What is available? So when you do that, then you can actually see that, after we run the chat, it will actually give you an entire detailed comparison between both cars, right? So nowadays, when I see a very nicely written email, I don't know whether it's from the AI or from the student, right? Because they can just generate it and then they can upload it there. I don't know how you do your assignments nowadays, but I guess this is a space that we need to improve on eventually, right? So actually, I have a lot more slides to go, but I will actually jump towards the last slide. These are just some examples of the projects that we have done, but I guess I'll just jump straight to the last few slides. Okay, because I see a note that says that it's time for me to finish. Okay, let's go to go to this one. Yeah. Okay. So generally, inside moving towards a smart factory, understanding how the process flow will look like is important, right? So I actually crafted out something called the Innovate, Accelerate, Transform. So basically, in building a smart factory, all you need to know is where to start and where does it go, right? So you have different levels of different technology implementation, but at every level, we always say you have to innovate first, then you accelerate, then you transform. Innovate means that you need to build use cases, pilot projects. Then once they are ready, then you accelerate them, then you transform. So this is a more practical approach to it compared to just buying technology overall, right? And what we do with a lot of companies in Malaysia is that we work closely with the companies. We build their people, and they will then implement the technologies that they need to implement. But sometimes certain technology use cases are very, very interesting that it's not really a recipe in place. So what we do is we work closely with universities. We work closely with the students and also the lecturers to actually come up with use cases, right, that will actually help the companies to grow. So MAHSA, I've been working closely with them on their IT students, and I can say their IT students are actually very good, right? I mean, they have been supporting a lot of our projects for quite a long time because the internship period is actually very long, right? So this is actually quite a good example, right? In fact, I still have some of the students that finish, even graduate, they're still helping me to look at some open source projects now. Yeah, which I think is a good practice for every student that is keen to learn, right? So this is how we work with companies. We help them build technology. We work with them to train their people, which also becomes building the next level workforce. So once you understand the technology well enough, it's actually quite easy to move forward. Okay. So this is the smart factory. We are not very far from MAHSA. Okay. Maybe about half an hour from here. Is it okay, Rosie? Half an hour, right? So we are located in Shah Alam. If in any case you would like to come and visit, okay, please arrange your lecturers. Okay, we are more than happy to host you at our center. Okay, all right. Yeah, this is our GitHub repo. If you want to look at some open source projects that we are working on, you can go on to our GitHub and have a look at those projects. Okay, and yeah, that's all I have to share. And open to any questions if there's time. Right. So anyhow, my contact details are on the Linktree link over there if you need. Okay. Thank you. Thank you very much. Okay. Yeah. Thank you. Thank you.
We have announcement to make. Attention to all staff and participants. Please scan the barcode for today's attendance.
We will wait for the barcode appear. So we'll take like 2 minutes.
Okay, please scan the barcode.
Kenapa open day? Hmm? Ada maintenance? Sini kan?
When you scan the barcode, there will be appear for the open day link. So please fill up the form. There is a join our research and innovation open day. So you may fill up the form for you to join our open day. Thank you.
For Wi-Fi internet connection, you just have to choose the Wi-Fi case. It's free access.
Staff with the password POIQ. Oh, please type. Oh, you need type. Please type the password. Okay, there is a password here. Okay, this is the password for Wi-Fi connection, MAHSA staff, and this is a password. This is the temporary password for today events. By the time this password will be reset. Okay, so this is combination for today event only. Thank you.
Yang mana yang tak penting tu je. Oh, kita ni student ke apa? Pelik je. Macam mana nak stop? Kan stop kat sana. Oh, leave kot.